Hey everyone, and welcome to another video. You are watching Ethical Explorers, the channel dedicated to uncovering the fascinating worlds of cybersecurity, ethical hacking, and mobile application security. Today, we have a really exciting and highly practical topic lined up for you. We are going to dive deep into mobile application security, specifically focusing on Android applications. When developers build an Android app, they package everything into an APK file, which stands for Android Package Kit. This file contains all the code, resources, assets, and configurations needed for the app to run on your device. However, a common mistake during the development lifecycle is leaving sensitive information hard-coded directly within the application's source code or configuration files. This can include backend server URIs, hidden API endpoints, cloud storage credentials, and various other secrets that should never be exposed to the public. To uncover these hidden gems, security researchers and ethical hackers use static analysis tools, and today we are going to explore one of the most efficient and popular tools for this exact purpose, APKLeaks. APKLeaks is an open-source static analysis tool designed specifically to scan APK files for URIs, endpoints, and secrets. It works by automating the process of disassembling the APK and then running extensive pattern matching using regular expressions to find anything that looks like a sensitive string. Before we jump into the hands-on demonstration, let's talk about why this is so critical. Modern mobile applications heavily rely on back-end web services. They constantly communicate with APIs to fetch user data, authenticate sessions, and download content. If a developer accidentally hard codes a production API key or an administrative endpoint into the APK, anyone who downloads the app can potentially extract that information. This could lead to massive data breaches, unauthorized access to back-end systems, or severe financial losses for the company. As ethical explorers, our goal is to identify these vulnerabilities before malicious actors do, allowing developers to implement better secret management practices. Now that we understand the theory and the importance of what we're doing, let's move on to setting up our environment. Getting APKLeaks up and running is incredibly straightforward, especially if you already have Python installed on your system. It is available directly from the Python Package Index, or PyPi. To install it, you simply need to open your terminal and use the pip package manager. You'll type the command pip3 install APKLeaks. Once you hit enter, pip will reach out to the repository, download the APKLeaks package along with any necessary dependencies, and install it onto your system. The installation process is usually very fast. You'll see a few progress bars on your screen as the packages are fetched and extracted. It might install some underlying tools and libraries that APKLeaks relies on to parse Android manifests and decompile Dalvik bytecode. Just let the process complete. Once it finishes, you should be returned to your command prompt, and you can verify the installation simply by typing APKLeaks --help to see the available options and confirm that the tool is ready to use. With the tool successfully installed, we're ready to start scanning. For our demonstration today, we are going to scan a sample application APK that we've prepared specifically for this test. It's always best to practice on applications that you have permission to test or those designed for educational purposes. We have the file, let's call it sampleapp.apk, sitting right here in our directory. To initiate the scan, the syntax is wonderfully simple. In our terminal, we just need to type apkleaks -f followed by the path to our target file. So we'll type apkleaks-f sampleapp.apk. Let's hit enter and watch the tool do its magic. As soon as we execute the command, APKLeaks springs into action. The first thing it does under the hood is decompile the APK. It extracts the contents of the package, including the Android manifest XML file, the compiled classes.dex files, and all the resource directories. This step is crucial because the raw APK is essentially a compressed zip archive, and the Dalvik executable files need to be translated back into readable text or Smalley code so that the tool can search through them. Once the extraction and basic decompilation is complete, APKLeaks begins the core scanning phase. It utilizes a vast dictionary of regular expressions to comb through every single file line by line. It's looking for anything that matches the pattern of a web URL, an IP address, or specific cloud provider keys like Amazon Web Services access tokens, Google Cloud API keys, or Firebase database URLs. This scanning process can take some time depending on the size and complexity of the application. A massive app with millions of lines of code and numerous third-party libraries will naturally take longer to parse than a simple utility app. While the tool is running, it's systematically documenting every single match it finds. It doesn't just look for obvious HTTP or HTTPS strings. It looks for custom URI schemes that might be used for deep linking, which can sometimes expose internal application logic or bypass security controls if not handled properly by the developer. It's also looking for hidden administrative endpoints that might be lingering in the code from the development or staging phases. Often developers forget to strip out these debug URLs before pushing the final build to the App Store. The scan is now complete, and our terminal is populated with the results. Let's break down this output. APKLeaks has categorized the findings to make it easier for us to digest. Right at the top, we see a list of discovered URIs. These include several backend API endpoints that the application communicates with. Some of these are standard endpoints for user authentication and data synchronization. However, as we scroll down, we notice something interesting under the Secrets section. The tool has successfully flagged a hard-coded Firebase API key, as well as an AWS S3 bucket URL that appears to be used for storing user media. This is exactly the kind of critical information we're looking for. In a real-world scenario, if these keys have broad permissions, a malicious actor could use them to read, write, or delete data directly from the cloud database, completely bypassing the application's intended security mechanisms. We also see several internal development endpoints that shouldn't be present in a production release. This output perfectly illustrates why hard-coding sensitive data is a terrible security practice. As you can see, extracting this information took just a few minutes and a single command line tool. Developers should always utilize secure backend environments to handle authentication and sensitive operations, keeping the secrets strictly on the server side. For any keys that absolutely must be on the client side, they should be properly restricted, obfuscated, and protected using advanced application shielding techniques. That wraps up our deep dive into APKLeaks and Android static analysis. I hope this demonstration highlighted how easily secrets can be extracted from compiled applications and why secure coding practices are non-negotiable in today's threat landscape. If you found this video helpful and informative, please make sure to hit that like button, share it with your fellow ethical cybersecurity enthusiasts, and subscribe to Ethical Explorers for more deep technical dives and practical cybersecurity tutorials. We have a lot more content coming your way, covering everything from network penetration testing to web application vulnerabilities. Thank you all so much for watching. Stay curious, keep exploring ethically, and I'll see you in the next video.